field of organic chemistry is broken down into the study of functional groups. And this is completely necessary because things in organic chemistry and related fields such as biochemistry get so complicated so quickly that it becomes impossible to understand unless we know what's going on at a very, very small level, and then adding up all those different pieces of information we know to get an idea of what is going on in the bigger picture. And then even at times then, we'll still not know completely what's going on, and we'll only have to make a best guess just from what we know through the study of similar structures. When thinking about functional groups, think of them as the new elements. The way in general chemistry, if we had a stoichiometry reaction, we would break it down into moles, break it down into the different elements. There are this many hydrogen atoms, there are this many carbon atoms, there are this many oxygen atoms. In organic chemistry, every time we get an organic molecule, we're going to break it down into these functional groups. Think of, as I said, think of it as the new elements for this field of study. And then from there, we're going to understand what those different functional groups, what their chemistry is like, what do they do, how do they react with other functional groups. And then from there, we're going to be able to get a bigger picture, a better idea for the bigger picture of what's going on. From this field of study, some fields of study, it's better to look at the bigger picture and then to go down into the smaller detail. In this field of study, we have to start at the smallest function, the smallest little building block, which is the functional group. We'll learn about the chemistry of the functional groups, and then from there on we'll build up larger and larger. That's how this field works. So we'll have a look at these functional groups. The majority of functional groups fall under the umbrella of one of these three: hydrocarbons, compounds containing oxygen, and compounds containing nitrogen. We'll have a look at the hydrocarbons first. These ones tend to be relatively simple. Alkanes are characterized by carbon-carbon single bonds. So here's a carbon bonded to 4 hydrogens. Normally we don't really include the hydrogens as anything in the field of organic chemistry. So here, carbon, 2 carbons bonded together, hydrogens attached, 3 carbons. This is an alkane, carbon-carbon single bonds. Alkenes are similar to alkanes, but they have a carbon-carbon double bond. And it doesn't matter how many carbon-carbon double bonds there are. As long as there is one, it is an alkene. So here is an example of one that has a single carbon-carbon double bond. And here is a single carbon-carbon double bond, but also a carbon-carbon single bond. It is still an alkene. If there were something like this, you could have a double bond. You could have something like this. So 2 double bonds. It's still an alkene. We'll learn about naming these different things later on to distinguish carbon, how many double bonds, where are those double bonds. That will all be talked about later. We're just learning the basic idea of the different functional groups for now. And then the last hydrocarbon type is alkyne, and it's similar to the other two, but instead of a single or double bond, it's a triple bond. Pretty easy to identify. Next are compounds containing oxygen. There are alcohol groups, which many people are familiar with. And this R is a symbol for carbon, so something like this. That means it's attached to a carbon chain. So an example might be methanol. So it's attached to 1 carbon. There can be stuff like this. And all this R means is that it's just attached to some carbon chain. It doesn't matter how long the carbon chain is. What characterizes the functional group is this. This is all we care about. Ether is an oxygen bonded to 2 carbons. So maybe something like this. ketone, carbon with a double bond to oxygen, and then two bonded to two carbons. So similar to an ether, but there's an oxygen double bond, and the carbon is what is bonded to two other carbons. An aldehyde is very much like a ketone, but instead of the carbon being bonded to two other carbon groups, it is bonded to a hydrogen and only one carbon group. Carboxylic acid, carbon bonded to another carbon with a double bond to oxygen, bonded to an oxygen with a hydrogen proton. This is going to be the acidic proton that's given up in reactions. And lastly, compounds containing nitrogen. There are amines, which are basically derivatives of ammonium. Amides, carbon chain, nitrogen, it's like an amine as well, but it's characterized by this double bonded oxygen here. And nitriles, carbon chain, carbon, and a triple bonded nitrogen. And that really covers it for the largest functional groups. There are other functional groups as well, but these are going to be the ones we're going to be dealing with for now. These are the most common ones. There are other types of suborganic things. There are organic metals, all kinds of other stuff, but these are going to be the most common and the most important ones for now. So focus your concentration on learning the chemistry of these basic groups, and then after we know these groups, we'll be able to go on to learning how to analyze larger and larger molecules and more complicated reactions.